In this short mini lesson, we're going to discuss how to factor a polynomial pattern known as the sum or difference of cubes. And notice that in this particular pattern, we can see sums as well as differences. When we were talking about a difference of squares, it was only differences. But in this one, we could have either a plus or a minus in between the two terms that are represented. Now, those two terms that are represented must be perfect cubes. So what is a perfect cube? Well, a perfect cube is nothing more than a variable or a value or an expression that is found by multiplying a different value, variable, or expression by itself 3 times. So for example, we could look at 1 cubed, 1 times 1 times 1, and we would know that that is the value 1. So 1 is a perfect cube. 2 cubed is 2 times 2 times 2, otherwise known as 8. So 8 is a perfect cube. 3 cubed is 3 times 3 times 3, which is 27. So there's a perfect cube. 4 cubed is 4 times 4 times 4, or 64. That's another perfect cube. 5 cubed is 5 times 5 times 5, or 125. If you know those first 5, those are great ones to know, but also 10 cubed is an easy one because 10 times 10 times 10, or 1,000, is also a perfect cube. All right, so let's look at the pattern. If you have something like this, where a cubed is added to b cubed, or a cubed subtracts b cubed, then what we end up with is a pattern with a binomial and a trinomial. Okay, so first we find the binomial, and the binomial is pretty easy to find. We're just going to take the cube root, or identify what is being cubed in the first term. So what's being cubed here is a. And what's being cubed in the second term is b. All right, and then what we're going to want to do is put the corresponding sign from the original expression. Okay, and so whatever happens to be in this expression is going to go in this expression. And if it's a plus, it's going to be a plus, and if it's a minus, it's going to be a minus. All right, so now we take that binomial and we use it to build the trinomial. We're going to take each of the terms in this binomial and multiply each of them by each of the terms in the binomial. So multiply them all by each other. So we're going to end up with a times a. A times a is going to give us a squared. Then a times b is going to give us ab. And then b times b is going to give us b squared. Now we need to fill in the appropriate signs. Now for this ab term, this is really important. The sign must be opposite what was in the original polynomial and the first binomial. If there was a plus in the original binomial, we will have a minus in the trinomial right there. And if we had a minus in the original binomial, we're going to have a plus in the trinomial in that position. Now that last piece, that b squared, is always going to be positive. So notice the first and the last are always positive. Some people use this acronym to help them keep track of the signs. This is always going to be the same as the original. This is always going to be opposite the original. And this back end is going to be always positive. So AP. So keep squeaky clean with soap. All right, so let's give it a shot. Let's look at this first example, 8x cubed minus 27. All right, and we want to think to ourselves, okay, what is being cubed to create that 8x cubed? Well, if we look here, we see that 8 is the same as 2 cubed. So this is going to be 2x cubed right there. Now, what is in the back there? 27. Oh, 27 is the same as 3 cubed. Okay, so once you've identified what's being cubed, that's going to create your binomial. You're going to take those items that were being cubed and put them in the binomial, keeping the same sign. So this is going to be 2x minus 3. Now we're going to use that binomial to create our trinomial. We're going to open up that set of parentheses, and we're going to start with a 2x. We're going to say 2x times 2x. That's going to give us 4x squared. Then 2x times 3 gives us 6x. And the 3 times 3 is going to give us 9. All right, now the sign in front of this 6x, since this is a minus, this must be opposite to make a plus. All right, and that's going to make everything cancel out for us if we were going to multiply it all out. And then the last term, that 9, is always positive, and so there we go. All right, let's take a look at the next example. What's being cubed to make us an x cubed? That's just going to be x. What's being cubed to make us a 64a cubed? Well, since 64 is 4 cubed, that's going to be 4a. And there we go with our binomial. X minus 4a is our binomial. Now let's use it to create and build our trinomial. Take that x, multiply it by itself, x squared. Take that x and multiply it by the 4a, so 4ax. And take that 4a and multiply it by itself, 16a squared. Put the appropriate signs in. Since this is a minus, this will be a plus. And the back end is always going to be a plus. All right, last one. In this one, look, 250 and 16, they're both even value. That means I can factor out a GCF of at least 2. Let's see what happens when I factor that 2 out. I take the 2 out, that's going to leave us with, I think, 125y cubed plus 8. And there we see a sum of cubes, which we can further factor. We can break it down a little further. Okay, so we're going to take that 2. It's going to just follow us along. And then this is going to break into a binomial and a trinomial. Okay, so what is being cubed to make 125y cubed? Notice that 125 is 5 cubed, so this is going to be 5y here. And this 8, of course, is 2 cubed, and we have a plus between them. So our binomial will be 5y plus 2. Now, using that binomial to create our trinomial, let's take that 5y and multiply it by itself, and it's going to give us 25y squared. And we're going to take that 5y, multiply it by the 2, it's going to give us 10y. And that 2 times itself is going to give us a 4. Right, now this plus means that this sign in the middle is going to have to be opposite or minus, and that end term is going to be positive because the end is always positive. Now that's about all there is to factoring sum and difference of cubes. I'll see you next time.